Hello, and welcome to Patch Math, where today we're going to continue talking about writing linear equations. Now, this is a broad topic because it depends on what you're starting with. You may recall this is what we did in the last video under this umbrella of a topic, and today we're going to talk about a slightly different part underneath that umbrella. So you'll notice I did modify the worksheet again because I don't want to jump straight to standard form. Honestly, I'm biased against it. It is the fancy form. I think it is not that useful. You see it in textbooks. It's there to make our lives miserable. That's about it. All right. Now slope-intercept form is super useful. It's dependable. It's there for you. So if you're going to be doing this problem, most commonly you'll be going through slope-intercept form to get the standard form anyways. So I'm just going to start there. Number 9 is a problem that I have assigned my students to do in their own time, and I am doing number 10 to help support them outside this lesson. All right, so we are going to write the equation of a line given this point and this slope in slope-intercept form. So let's start with slope-intercept. You may recall this from the last video. I'm going to go ahead and put it underneath the problem assigned to my students. B is our y-intercept. Now, here's a cool thing. If you were given a y-intercept here, and you would know that. Normally, I would ask a leading question there. How would you know if you were given a y-intercept? Well, you would know because the x value attached to that, because the x value attached to that y value would be 0 in the ordered pair. But our ordered pair does not have a x that is 0. Our x is 3. So we were not given our y-intercept. We're going to have to find that here. Now, we were given, though, our slope is super important. All right, so when we look at an ordered pair, what are we being given? We are being given the x and the y value of a point on our line. So that's x and y. Look, we have an x that we can temporarily fill in. We have a y we can temporarily fill in. So that way we can find that b. And so that's just what I'm going to do. I'm going to take y equals mx plus b, and I'm going to write my y, -1, equal to my m, which also happens to be -1 there in green. And we're going to be multiplying that by our x, which is 3. And the b we do not know. But what's awesome here is that through simplification and solving techniques, we can quickly find our b. The first thing we are going to do is simplify down the -3, pardon me. First thing we are going to do is simplify down the -1 times 3. So we end up getting -1 equal to -1 times 3 is -3. And that is being added onto that b. Now, there's no more simplification that can be done, but we can solve. We can launch into solving here. And you will notice that although this -3 is attached by addition, we were to use the commutator property here, we'd actually find that that 3 is being subtracted off. So how do we get that 3 to go away? Well, we add 3 to both sides because what you do to one side of the equal sign, you must also do to the other side of the equal sign to retain the original value of the original equation. Now, -1 plus 3 is 2. This cancels. That was the point, and we have b on its own. Once we know b, we have everything we need to write slope-intercept form of this line. Now, notice this is a part that confused me as a student. When you are writing a equation for a line here, your x variable and your y variable stay as variables in the equation. That represents any x or y on that line. And we can find any x or y on that line by taking the slope and the y-intercept. Slope and the y-intercept and finding the other points on that line. So all you need is slope and a y-intercept. You can find any x or y on that line, and that's why we leave that open there. So we can find any x or y on that line. Now that is the slope-intercept form of this equation. In the next video, we're going to go back to the original question here, and we are going to convert this to standard form. Until then, thank you so much for your time.